Hey class, this is Mr. Bean here, and we're going to be presenting video 1.2, Acceleration. This is for Unit 1 AP Physics, continuing our summer series here. And in this video, we're going to, from the note packet or from the study guide, we'll be covering questions 3.15 to 3.18. And before we start, I had some people wanted to distinguish between uh, distance and displacement. And here's a good video to discuss, or good picture to differentiate that. So if I'm starting here, this will be XO right here. And uh, displacement is, and so here, this person travels along this way right here, ends up here. So this total, uh, uh, well, this is actually his distance. How far did the person actually travel? That would be distance. And displacement is wherever he ended at. Here's our starting point. It's a vector, a straight line from his start to his ending position. So this would be delta x here, where this here would be distance. And I hope that kind of helps, differentiate between displacement and distance traveled. Okay, let's go back to here. Okay, now we're going to be talking about acceleration. So acceleration is basically, to me, it's like, okay, so if I was going to explain acceleration, here's how I would do it in a nutshell. Go ahead and get rid of this here. All right, so acceleration in a nutshell is something, an object is speeding up, slowing down, or changing direction. Acceleration is, again, it is a vector quantity, and so magnitude and direction makes a difference. So go ahead and take a look at this here and read about acceleration and examine the formula and note the units here. There's some units for acceleration. It's now meters per second squared. That's the SI unit. So go ahead and take a look at this here, and then we'll look at 3.15. Okay, so here's 3.15. Start off kind of relatively straightforward here. Read number 3.15 and go ahead and give the solution. All right, so here's the solution for 3.15. It should be 3 meters per second squared. And notice in here, the initial speed is uniformly from rest. Whenever you see rest, that's going to indicate 0. So unless they tell you otherwise, you can assume it's from rest or it's from 0. Okay. Take a look at 3.16. Velocity is to speed um, as velocity is to speed as displacement is to what? Okay, so for 3.16, velocity is the speed as displacement is to, should be distance there. Okay, so is the vector equivalent, okay, distance. Okay, here we go. Here's some other manipulations here we can do. The definition of acceleration can be arranged to show a relationship between velocity, acceleration, and time. So here, this will give us the final velocity given initial speed and acceleration. Now, it should be noted that the acceleration here is constant. It is not changing. And we'll want to make a note of that here. Acceleration is constant. It's not changing. So constant acceleration, this holds true. Okay. And now, for right now, we're going to just deal with the x direction. Later on, when school starts, we'll do the y direction. So these are all really, should be a subscript 0. This means velocity in the x direction, original, and acceleration in the x direction. So all these are just linear in the x direction. Okay, so if I draw my axis here, let's go ahead and go over here and draw our axis. Hold on, let me go to right here. Just do some drawing here. That means that on our coordinate axis here, we are only dealing with the x-axis at this time. Okay, we'll deal with y a little bit later. Okay, and focus on one dimension. Otherwise, you can be due to, it can be generalized to multiple dimensions. Okay. All right. So here's 3.17 here. Take a look at this answer here and kind of like see what we got going on. Okay. Before we start here, let's go ahead and make sure we have our axis system here. Okay, remember this is going to be east here, and this over here is going to be west. Okay, and let's see what we got here. Okay, so 45 meters to the west. Okay, so we're going to take west to be negative, east to be positive. Okay, and here's our initial information here, and we want to find the acceleration. So that's going to be v minus. Now I'm going to go ahead and be careful. Now I'm going to go ahead and put this. I'm going to put VO here, just to make sure that we're careful here. I have double negatives and stuff, and this is over time here. Okay, so we want to use this equation and see kind of where we're at. Okay, so here's the solution here. We have the initial velocity is negative because it's going to the west. East is positive, and we have the time there. And here's the acceleration. So we should be able to get 8,000 meters per second east. Okay, east. Okay, now go and take a look at read this here and see what's going on here. Go and take a look at this here and see what we got going on. Okay, now go ahead and read this, and I'm going to draw a little chart here that kind of gets all the signs in the right order. Okay, so bear with me here, and I want you to kind of think about this as we go along here. All right, so what I want you to do is go ahead and copy this down. I'm going to make a little chart here, and this will kind of help us kind of get things organized here. All right, so let's take a look here and see the situation here. Okay, so let's go ahead and let's let me go ahead and pause real quick. Okay, so what I'm going to do is I'm going to go ahead here. I'm going to go ahead and write V here for velocity here. Okay, because these are vector quantities. Here's the acceleration. These are vector quantities. And over here, I'm going to go ahead and write down the result. Like what's going to happen here? What is it that's going to happen? Okay, so we'll go here. All right, so suppose the velocity is positive and acceleration is positive. What's going to happen here? It's going to speed up, right? Speed up, or get faster. Okay. What happens if the velocity is positive and acceleration is negative? Okay. That means we're going to slow down. Okay. What's an everyday experience? Okay. You're driving in a car and you apply the brakes. Okay. Brakes on a car or on a bicycle. Okay, that could be a good example. Okay, now I'm putting the car in reverse. Okay, going backwards. And also the acceleration is also negative. The signs are the same, so it's going to speed up backwards. Okay, speed up backwards. Okay, backwards. Okay, all right. Now we should maybe just let you know that this to the right is forward, and to the left here is backwards, just so we have some reference frame. And then what happens if I'm going backwards, but the acceleration is uh, positive? What's going to happen now? Okay, opposite signs. I'm going to slow down. Absolutely, we're going to slow down. Okay, now some other scenarios here. Okay, some other scenarios. Let me use different color. Let me use black here. Okay. What happens if my velocity is positive and my acceleration is 0? Okay, that means what? Constant speed? Constant. It's going to be constant. Go ahead and write that down. It's going to be constant in the forward direction, right? Okay. Um, what happens if my speed is negative and my acceleration is 0? I'm going to be going constant again. So constant. There's constant, and but going backwards, right? Going backwards. Okay. What if my speed is 0 and my acceleration is 0? Uh, Not moving, right? Not moving. Not moving. Okay. And what if my velocity is constant, but my acceleration, let's say, we'll say is positive. Okay, what does that mean? It means I'm going in a circle, going in a circle. So if I'm like this right here, right? So at this point right here, I'm going to draw a velocity vector. So I'm here, then at this time here, okay, my velocity vector is the same magnitude. It's not changing. The magnitude, assume that all these magnitudes are the same. But at each point, what's happening here? My direction is changing. So my direction is changing, so my speed is the same, but my velocity, but my direction is different. So my velocity could be positive. Maybe going to the left is positive, going to the right is negative. So I'm going in a circle, okay? Going in a circle. Okay, constant velocity, okay, going in a circle, okay. Um, what if my velocity is 0, but my acceleration is positive? Maybe I'm just, spinning, spin in place. I don't know, that could be an example there. I'm spinning in place. Uh, I'm rotating in place. I'm spinning. I'm moving in I'm staying right here, and let's say I'm spinning. Okay. Uh, Hold on. Let's ignore this for right now. We'll save this for rotational motion. I don't want to get too far ahead. Okay, uh, but yeah, let's just save this for here. Okay, and then so constant speed, and okay, what would happen if my acceleration is constant? Okay, what would be the choices here if my acceleration is constant? Okay. If that's the case, then uh, this could be what, either plus uh, or negative, right? Okay. Okay, means that okay. If it's constant, now it's going to be or it's positive or negative, but it's going to be increasing or decreasing, right? So what's going to be the result here? A constant velocity, constant acceleration, it could be increase. Okay, increase or decrease. That could be the result. Decrease in speed. So my speed could be increasing or decreasing. Okay, kind of depending on the situation here. Okay, all right, means to increasing or decreasing, going forward or backwards, depending on the situation. Okay, all right. Well, I don't. Yeah. Okay, I don't really like that because acceleration is positive. Well, actually, in all of these cases here, the acceleration is constant. The positive negative just means increasing to the left or to the right. Okay, because forward means positive, and that means negative. Okay, all right. I just wanted to clarify this here that these are more for direction. Okay, these are more for direction. Okay, all right. So in all of these cases here, the acceleration is constant. Okay, all right. All right, so go ahead and take a look at particle diagrams and read the description here and what's going on, and then we'll look at the next question here, which should be 3.18. Okay. Okay, so 3.18, the diagram below, okay, it says, can you think of a case in which the car could have a negative velocity and a negative acceleration, yet be speeding up? Draw or instead of draw a picture, I want you to explain to me in a paragraph what you would do in an essay format. So go ahead and answer this question right here. Instead of drawing a picture, I want you to explain to me in Edpuzzle an essay about how you would do that. Okay. All right. And then finally, 3.18. The diagram shows a car beginning from rest and accelerating uniformly down the road. Okay. 3 seconds, 4 seconds. It says here, what is the average speed of the car between 2 and 4 seconds? Average speed of the car between 2 and 4 seconds. Now, caution, it's asking for average speed, right? So remember, what was average speed again? So here's average speed. It was the distance covered divided by the lapse time for that. So keep that in mind. All right, it looks like the answer here is 12 meters per second. All right, that will conclude video 1.2, and then we'll see you for video 1.3.